Alright, so in the last video we got our character moving, but we observed some problems. One of the problem was there was no max speed, so actually maybe what I'll do to kind of exemplify this further is just extend my test level. So I'm going to use the face select here, and right now I think it's 20 by 20 or something like that. We'll just go out 10 more. And let's go even farther. Let's go 20 more. I think that's 20. Each of these big grid lines is 10 units, 10 meters in Unity. So now I have like a longer runway here. Let's run the game, and you should notice that I can really get going. Oh, well, never mind. My camera isn't going to move with my character. Why don't we drag the game camera over so that we can actually follow the action in the scene camera? Eventually we'll get a real camera going, but I don't want to focus on that just yet. So I'm going to run the game, and the game camera is really kind of irrelevant for me right now. I want to focus on the scene camera to see how the character is just going to keep building speed. Alright, so we want to cap the player at some max speed. So we're going to have to head into the script to take care of that. So I'll double click my script here. And I guess I know right away that max speed is going to be something that should be a serialized field so that design can, oops, just a sec, can, tweak it. And we don't want it to be a magic number, so we better make a variable for max speed. And I don't know, we can just initialize it at something. Let's make it small, just to, that way it'll be very clear whether or not it's working, I suppose, just as we observe. And so in fixed update, we need to enforce this max speed. There are a couple ways we could do this, but one way I want to kind of mess with right off the bat is to use this idea of clamping the vector3. So there is a function called clamp magnitude we could try. So let's say rigid body dot velocity equals vector3 dot clamp magnitude, which in theory is going to let us clamp our rigid body's velocity to some new value. So we have to tell it what the initial vector we want to clamp is, which would be rigid body dot velocity. And then we have to tell it what's the max speed, or the max length in this case is how they're phrasing it. So we will say that is max speed. And that's all that takes. Let's save it and check it out. We'll go back to Unity. We will run the game, and in theory my character will be a lot slower as I try to move forward here. And you can see it's moving at a constant rate once it hits this max speed. And we can test it. Why don't I will, so I'm still on face select here actually. I need to make sure I go back to object select, click on my player, I'll grab him on the Z, just move him back while the game is still running. And I'm going to go down here and mess with max speed, and just to confirm this is doing something, let's increase the max speed. So I'll click in the game window so that my input gets captured by the game, and you can see he's going much faster. I can drag him back and try one more time. We'll put it at something very small, 0.5, and now he's going this fast. So this is working. I wish I could just keep holding forward while I drag this, but what will happen is once I select this window, the game window is no longer the active window, and my input will get captured by this inspector window, and it won't get passed into the game, so the character just stops because it's not detecting any input anymore. Anyway, we know it's working, but what is the problem here? Let's go back to this 0.5. This would work fine, except the velocity, when we start directly changing the velocity of the character, we're going to be artificially removing our character from the natural physics simulation, which is part of why we aren't just using velocity as our way that we're moving the character. We could just change the character's velocity, like I mentioned in the first video, as a way to move them. But in order to like demonstrate that, watch what happens if I drag the character up. See how slowly he's falling? That slow fall is based on the max speed here. Now, because the gravity is constant and isn't based on my input, I can drag the guy up here, and then now as I increase max speed, you'll see he'll fall faster. So we don't really want max speed to impact gravity. That's not the intent. So unfortunately, I think this solution that we used is no good. But I wanted to do it anyway, just so you can see a good example of why we're not trying to directly change velocity, because it's going to overwrite the Unity physics simulation. So there's a variety of ways we could work around this. I'm going to use one that I think is a balance between effective and also not too time consuming or confusing. So all I'm going to do is, instead of just adding the force every frame if the player's pressing the button, let's only add the force if our current velocity is less than the max speed. So we'll just say if rigid body dot velocity dot magnitude. So magnitude just tells us, like, it's like a float that measures how fast or how big a vector is. So in the terms of velocity, it's like your speed essentially. So if the magnitude is less than the max speed, then we want to do add force. So I'm going to hold Alt and press the up arrow to move that up there, and then I'll hit Tab to fix that, and then I'll go down here and get rid of this empty blank space. And now we are only going to add force if we're less than the max speed. And if we're not pressing the button, the input is going to be 0. So this will essentially add a 0 force. So that's nothing that we need to worry about. All right, let's save and test this one out. So let's again put the max speed very slow. I'm going to run the game, and you can see I'm moving very slow. If I crank it up and I click back in the game window, I can get going pretty fast again. All right, so that satisfies max speed, but we still have this issue where we can slide around. So in the next video, we'll work on improving friction so that the character, maybe that's desirable. It really just depends on the game you're trying to make. And like I said, we don't know what that is. It's super abstract, which makes it hard. But again, I'm trying to show you some techniques to explore ideas. So in the next video, we'll look into friction and see how that can affect this simulation here.